So this video will cover examples from the Unit 2 review. For number 1, you are given two equations and asked to solve them by graphing. So in order to graph each of these equations, we need to solve for y. So my first equation, I'm going to subtract 3x from both sides of the equal sign. So I have positive 6y equals negative 3x minus 24. And then I need to divide by 6 on all three terms. So I have y equals, and a negative 3 divided by a positive 6 is negative 1 over positive 2x. And then negative 24 divided by 6 is a minus 4. So that means that my slope is negative 1 over 2, and the b is negative 4. And another way to write that is 0, negative 4, to write that in an ordered pair. So then my other equation, to solve for y, I'm going to subtract x on both sides of the equal sign. And I have y equals negative x minus 6. And there are no other steps, so the m is the number that's in front of the x, and right now there's just a negative sign, so that means negative 1 over positive 1, and the b is negative 6, and again, another way to write that is 0, negative 6. So now we're going to graph each of these equations. So the blue equation, I'm going to start at negative 4 on the y-axis, and that slope indicates that I need to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. And I'm going to do that across the entire grid. And when you're working this out on paper, you'll want to do that, especially if you don't have a ruler. Okay, then I'm going to make this line, as straight as I possibly can. Okay, and then the other line, I begin at negative 6, and I go down 1 to the right 1, down 1 to the right 1, and I'm going to keep doing that until I reach either the other side of my grid or where my graph matches up. Okay, so up 1. Up 1 over 1. Okay, so then I'm trying to draw this as straight as I can. Okay, and where these cross, which doesn't look too fantastic on this, is at this point right here. So that point is negative 4, negative 2, because if you start at the origin, you go to the left 4 and down 2. So the solution is this ordered pair, and it's where your two lines cross. All right, so on number 2, you're asked to solve the systems of equations by substitution. So when we have substitution, we should write our two equations side by side. And in this one, it's nice because one of the equations already has a variable by itself. This one has x equals, so I don't have to do anything to these first two equations before I start substituting. So I'm going to take the 5y plus 9 because it is actually equal to x. And in this equation, I'm going to put it in for this x. And now I'm going to solve this equation for a y. So what I will have is 3. And then instead of writing the y, I will write 5 y plus 9. And I said instead of writing the y, I should have said instead of writing that x, I'm going to write 5y plus 9. And then you can't forget about the rest of the problem that's already there. So plus 7y equals 5. And now I'm still working with this equation and I'm solving for y. So to do that, then I need to distribute. So 3 times 5y gives me 15y. And then 3 times 9 gives me the plus 27. And I still have the plus 7y equals 5. And at this point, I should only have the one variable. I have a 15y and a 7y, but they're both just a y. So I need to combine those. So 15y plus the 7y would give me 22y plus 27 equals 5. And then I need to continue this equation to solve it for y. So I have to scroll up here a little bit. Okay. So my next line, I would subtract 27 on both sides of the equal sign. So I've got 22y equals, and then in your calculator, do 5 minus 27, which should give me negative 22. And I will divide by 22 on both sides of the equal sign. And that leaves me with y equals negative 1. So now I have solved half of the equation because half of the solution. My answer will be an ordered pair. So now I can take that y that I just found, which is negative 1, and I'm going to take that negative 1 and put it in for that y. So when I rewrite this equation, I will write x equals 5, and instead of the y, I will put negative 1, and then I still have the rest of that equation plus 9. So now x equals, and I have 5 times the negative 1, so negative 5 plus 9. So x will equal negative 5 plus 9 is 4. So my ordered pair answer, the x value comes first, so it would be 4 comma negative 1. So problem number 3, we are solving the system's equations by elimination. Elimination, we want to stack those equations right on top of each other. And so what we're trying to do is eliminate or get rid of either these x's or these y's. In order to do that, the signs need to be opposite from each other. So these y's already have opposite signs. One is a minus, one is a plus. But then they need to have the same number in front of them. So I can get that to happen if I multiply this top equation by a positive 3 and multiply the bottom equation by a positive 2. So what that does is we're going to distribute that 3 to all of the numbers because all of those numbers, all those terms are in parentheses. So 3 times 3x is 9x. 3 times negative 2y, negative 6y, equals 3 times negative 2, negative 6. And then the bottom equation, we are multiplying the 2 times all 3 terms. So 2 times 2 gives me the positive 4x. 2 times 3y gives me a positive 6y, and that's what I wanted because I wanted to eliminate the y's. And then equals, And 2 times the 29, and if you don't know that, then go to your calculator, or if you just want to make sure that you have done the right calculating. So 2 times 29 gives me the 58. And now that I'm ready to eliminate, I'm actually adding these two new equations together. So 9x plus 4x gives me a 13x. Negative 6y plus 6y eliminates. I have my equal sign, and then I've got negative 6 plus 58. And again, there's nothing wrong with using a calculator just to make sure that you write the right problem. So 52, and then I'm going to divide by 13, divide by 13. And so x equals, and again, you can use the calculator, 52 divided by 13 gives me 4. So just like problem number 2, I've solved half of the equation now. So I'm going to plug that 4 back into one of my equations. A lot of times I use the equation that doesn't have any negative signs. A lot of times I use the equation that is on the first equation, so it doesn't really matter. Let's see, we will use the 2y plus, or 2x plus 3y equals 29. So this 4 is going to go in for the x. So 2 times the 4 plus 3y equals 29. So 2 times the 4 is 8, plus the 3y equals 29, minus 8 on both sides of the equal sign. So 3y equals, and again, nothing wrong with using the calculator to do 29 minus 8 to make sure that you do the subtraction correctly. That equals 21. And then we're going to scroll up just a little bit. And we will divide by 3. So we got y equals 7. So our final solution is an ordered pair. We put the x first, which is 4, the y second, which is 7. And that is our solution to that system of equations using elimination. So number 4 is an application problem where your problem should be very similar to this. A store sells small notebooks for $6 and large notebooks for $12. If a student buys 6 notebooks and spends $54, how many of each size notebook does he buy? So I believe on our work page, we have asked you to define variables. So x would equal, and I'm just going to use number of small notebooks because that's the first thing they talk about. And I'm going to use y as my other variable, and that's going to be the number of large notebooks. So all that is called is just defining your variables. And then you actually have to write your own system of equations. So you're going to write 2 equations. So a store sells small notebooks for $6. So I can say 6x, because that would be $6 per small notebook, plus $12 per large notebook. And since those are both money, I'm going to use the $54. And then The other equation just talks about the number of notebooks that were purchased. So the number of small notebooks plus the number of large notebooks was 6. And so we've learned 3 ways to solve systems of equations: by graphing, but we didn't give you a graph to do this on, so we probably would prefer you to do it with substitution or elimination. And I would say this is set up nicely for elimination. So I would like to eliminate, and it doesn't matter whether you eliminate the x's or the y's, but we can go ahead and eliminate the x's. And so I am going to multiply my bottom equation by -6. And so my top equation stays 6x plus 12y equals 54. But then my bottom equation, I need to distribute that -6 to all 3 terms. So then it's -6x, and -6 times y would be -6y. And then -6 times 6, and if you need to use your calculator to get -36. Once I have what I would like to eliminate, then I'm adding my 2 new equations. So positive 6x minus 6x, those cancel. 12y minus 6y is positive 6y equals, and then I've got 54 minus 36, which gives me 54 minus 36 gives me 18. And then divide by 6 on both sides of the equal sign. So y is going to equal 3. So now I know how many large notebooks were purchased. So to find out how many small notebooks were purchased, I am actually going to go back and use the equation that's in that kind of aqua blue color. So the x plus y equals 6. And so this 3 now is going to substitute into that x, into that y. So x plus 3 equals 6 minus 3 on both sides of the equal sign. So x equals 3. So then if you're asked to answer that in a sentence, then you can write something just as simple as, sorry, let me get my pen back. You can write something as simple as the student bought 3 large, or really, I guess small, 3 small notebooks and 3 large notebooks. Number 5 is the solving of a system of 3 equations. So the first thing that we'll want to do is we're going to take 2 of the equations. Now, if I look at equation 1 in red and equation 2 in blue, it's already set up to eliminate the b. So I'm going to go ahead and try that. Now you can do, different, you can do these in different order, whatever you see is easiest, but we're going to get rid of the b's on this one. So I'm just going to take equation 1 and equation 2, and because they're already set up nicely to eliminate, I'm going to go ahead and do that. So I'm going to add those two equations together. Oh, I don't know why that didn't go with it. Okay, so I'm going to add these together. So I have 4a plus invisible 1a. That gives me 5a. My positive 3b minus 3b cancels. Invisible 1c plus 2c gives me plus 3c. And then negative 5 minus 25 gives me negative 30. So now I need to take two of the equations, a different set of two equations, and eliminate the b. So if I look at the red and the green, the b's already have opposite signs. So I'm going to eliminate those. So let's see here. I said equation 1 and equation 3. Now these two, I can't just go ahead and eliminate the b without doing something first. So I need to multiply the first line by positive 2, because that would make that a 6b. And then I can multiply the bottom equation by a positive 3, because that would make that a negative 6. So I'm going to rewrite below this. So let me just make a little, I'm going to write below that. So the 2 times 4a gives me 8a. 2 times 3b is plus 6b. 2 times c plus 2c. And then 2 times negative 5 gives me the negative 10. Now on bottom, 3 times 11a, 33a. 3 times negative 2b, negative 6b. 3 times positive 3c plus 9c. And then 3 times negative 56 gives me negative 168. And now that I'm ready to eliminate my b's, I can add those two equations together. So 8 plus the 33 gives me 41a. The 6b minus 6b cancels. 2c plus 9c plus 11c. And then the negative 10 minus 168, use your calculator, and it's negative 178. And so now I have two equations. Here in the purple, 5a plus 3c equals negative 30. And here in the kind of orange color, 41a plus 11c equals negative 178. So they're not very nice numbers, but we're going to put those two together and eliminate either the a or the c. So I'm going to scroll up a little. Okay. So what I've done is written in blue. I just took the equation in pink or purple and the equation in this orange color and just wrote them on top of each other. And so now I have to either eliminate these a's or the c's. And to me, it looks like it might be a little easier to eliminate the c's because I can make those 33. So the top equation, I'm going to multiply times a negative 11. because what that will do is make this a negative 33. And then on the bottom, I can multiply this equation by a positive 3, because that will make this a positive 33. So over here to the side, okay, I've got negative 11 times 5a. So that gives me negative 55a. And then negative 11 times positive 3c, negative 33c. Negative 11 times negative 30. So in your calculator, you can just double check. Negative 11 times negative 30 should give you 330. And then we have the positive 3 times 41. And that gives you 123a. Positive 3 times positive 11 is plus 33c. Positive 3 times negative 178 gives us negative 534. And now we can eliminate the c's. So I can add my two equations together. So negative 55 plus 123 gives me a positive 68a. I can get rid of the negative 33 and the positive 33 equals, and then I've got 330 minus 534, and I get negative 204. Then I will divide by 68. Divide by 68. And so I should get a equals, so negative 204 divided by 68, and I get negative 3. So that was to find one of the variables. And so now I can take this a equals negative 3, and I can put it back into either this blue equation or this blue equation. And once I do that, I'll be able to get C. So we're going to scroll up so we've got some more room. So if I take that very first blue equation right there, so 5a plus 3c equals negative 30, and I put this negative 3 in for the a, I'm going to have 5 times negative 3 plus 3c equals negative 30. And then I'll solve for that c. So 5 times negative 3, negative 15, plus 3c equals negative 30. And then I will add 15 to both sides of the equal sign. And so I don't know how I got some crazy colors in there, but this gives me 3c equals negative 30 plus 15 would be a negative 15. Divide by 3, divide by 3, and my c is negative 5. So now I have two of the variables that I was looking for. So now I can go back into one of my three original equations, which I know we can't see on our screen anymore because I had to scroll up. But one of them, so I'll have to scroll up again. Okay, one of the originals was A minus 3B plus 2C equals negative 25. And so I know that the A is negative 3, so I can put a negative 3 in for A, minus 3B, and I know that C is negative 5, so I can put plus 2 times the negative 5 equals negative 25. Try to finish it over here. So I've got negative 3 minus 3B minus 10 equals negative 25. I can put the negative 3 and the negative 10 together and get negative 13 minus 3B equals negative 25. Add 13 on both sides of the equal sign. And get negative 3B equals, and negative 25 plus 13 gives me negative 12. And then if I divide each side by negative 3, I have B equals 4. So our final answer, our A was negative 3, the B is 4, and the C is negative 5. And again, there are many, many different ways to do this with many different steps. That was just one way to try to solve the systems of equations with 3 variables and 3 equations. Number 6 is also solving a system with 3 equations, but as you can see, this one only has A, B, this one has A, C, and this one has B, C. So it is solved a little differently from number 5 that we just did. So the first thing we can do, and again, many different things, but if I just look at equations 1 and 2, I have to eliminate either, well, the only thing I can eliminate is the A, because that's the only thing they have in common. So to eliminate that A, I can multiply my first equation by negative 2. So that will give me negative 8A minus 14B equals negative 2 times 19 is negative 38. And then my bottom equation would stay the same. 8A plus 2C equals negative 40. And now that I'm ready to eliminate, I can add these 2 equations together. So negative 8A plus 8A cancel. And I can't put these together because one's a B, one's a C. So negative 14B plus 2C, I'm just going to write them side by side. And then negative 38 minus 40 would give me negative 78. So now that I have an equation that has just a B and C, I'm going to use the equation over here that has just the B and C. So I'm going to take that blue equation of 6B plus 2C equals 22, and then this orange equation of negative 14b plus 2c equals negative 78. Now, these cannot cancel yet because they're both positive. So to make one of those equations negative, I need to multiply by negative 1. So this now will become negative 6b minus 2c equals negative 22. The bottom equation stays of negative 14b plus 2c minus negative 78. So now that the c's are ready to be eliminated, I can add my equations. Oops. So negative 6b minus 14b, use your calculator. Negative 20b, negative 2c and plus 2c cancel. So now negative 72 or negative 22 minus 78, use your calculator, gives me negative 100. Divide by negative 20, divide by negative 20. So I end up with b equals, and if you need to use your calculator and make sure you have the signs right and everything, that'd be fine. B equals 5. So we actually have two equations that have a b and then one other variable. So I can plug that b into either equation 1 or equation 3. So we'll scroll up. Okay, so we found the b. So I wrote down equation 1 right here and just substituted in the 5. And then I got my 7 times 5 is 35 and ended up with an a is negative 4. So we're going to scroll down so that we can find C. So I'm going to take 6b plus 2c equals 22. So now I have 6 times that 5 that I found plus 2c equals 22. So now I have 30 plus 2c equals 22. Going to subtract 30 on both sides of the equal sign. So 2c and then 22 minus 30 should give me negative 8. Divide by 2, divide by 2, c equals negative 4. So then when I'm ready for my ordered triple, my answer will be A was negative 4, B was 5, C is negative 4. On number 7, you are given a couple pictures of graphs, and you are to decide if the ordered pair you are given is a solution of that graph or not. So for me, the 0.32. Now, if the point is in the shaded area, it is a solution. If the point is not in a shaded area, it's not a solution. So my point of 3,2 is right here, and it is in that blue shaded region. So I would be picking A. B, here is my 3,2. Well, that's not in the shaded area, so 3,2 is not a solution of the answer choice B. For number 8, you are given an inequality and asked to graph it. So the first thing you'll have to do before you can graph anything is to solve this equation for y. So just to make it easier to not have to worry about this symbol until we're ready to shade, we are going to change that inequality to an equal sign so that when we solve, we don't have to worry about it. I'm going to subtract 5x on both sides of the equal sign. So that leaves me with negative 6y equals, and remember that the negative 5x and the negative 30 cannot combine. We divide by negative 6, divide by negative 6, divide by negative 6. So y equals, and a negative divided by a negative is a positive. So if you put in your calculator negative 5 divided by negative 6, you would get positive 5 over positive 6x. Negative 30 divided by negative 6 would be positive 5. So to graph this, our slope is positive 5 over 6. Our y-intercept is 5. Now we have to decide if we are going to be graphing with a dotted line or a solid line. Well, ours is going to be dashed or dotted because our symbol was a less than. It would be a solid line if I had the equal to underneath it. And then to decide which side of the line to shade on, we go back to the original equation, the original inequality, which was 5x minus 6y is less than negative 30. And I'm going to put a 0 in for that x, a 0 in for that y. And so what I have is 0 is less than negative 30. Well, 0 is not less than a negative number, so that answer is no. So that tells me that when I shade, I'm going to shade away from that 0, 0, which was my test point. So let's get this graphed. I start at the positive 5, and I go up 5 over 6. And since I've run out of room, I can do the opposite, which is to go down 5 and to the right, or I'm sorry, to the left, 6. Now, our line was dashed, so we make the best dashed line we can here. And my test point was 0, 0, which is right here. And so when I used my test point, I got an answer of no. So I don't shade over the 0, 0. I shade on the side of the line that does not have the 0, 0. So that would be over here. So my shading is here. And it goes all the way up to that dashed line. So number 9 is another one of our applications. A freight elevator has a capacity of 3,000 pounds. That means that it can't hold any more than 3,000 pounds. If a barrel averages 40 pounds and a crate averages 120 pounds, write an inequality that describes X number of barrels and Y number of crates that will cause the elevator to be overloaded. So if I define my variables, I'm going to say that X is the number of crates, I want to do number of barrels, and that Y equals number of crates. And so writing the inequality, I'm going to say 40 times X plus 120Y, 40X plus 125 or 120Y. If I'm looking to overload the elevator, then that amount would have to be greater than 3,000. It can hold 3,000, but if it has any more than 3,000, which is what this would be, then it would be overloaded. And that is what they're asking. they're asking will cause the elevator to be overloaded. So then you'll have to indicate which graph goes with this. So we are going to use the method of finding the x-intercept and the y-intercept. So to find the x-intercept, I'm going to put a 0 in for the y. So that means that 40x, and I can make this an equal sign while I'm solving it. So 40x equals 300. So divide by 40. That means that x is 75. And so a way that we can write that in a point form is 75 comma 0 because it's an x-intercept. Now to find the y-intercept, I'm going to put a 0 in for the x. So now I have 120y equals the 3,000. Divide by 120, divide by 120. So my y equals 25. And so I write my y-intercept is 0, 25. So when we go to graph this, this is going to be kind of a not fantastic graph, but if I have my graph where I have my crates and my, actually that should be barrels. Barrels would be along the bottom. So my barrels and my crates. So X, that was my barrels. So my barrels would need to be 75 and my crates 25. And then I've got my line, which is actually should be dashed. I don't know if I can make this dashed or not. Maybe a little bit. And so anything that's over these would be the overloading. So our shading would need to be on this side. So that should help you to indicate where, which graph you should pick for number 9. On number 10, you are given 2 inequalities, and then you're asked to graph both of those inequalities on the same grid. So we're going to have some shading, which means we're going to end up having some super shading because there are 2 equations. So for my blue equation or inequality, the m is 2, and we can write that as 2 over 1. The b is 2, which we can write as 0, 2. And so to graph that blue one, I'm going to start at positive 2 and up 2 over 1, up 2 over 1, and I can do that through my entire graph. And to decide if it is dashed or solid, I look at my original symbol. And since it has the equal to underneath it, then this line is going to be solid. And now to decide which side of the line I need to shade, I'm going to go back to my original. And I'm going to put, so my original is y is less than or equal to 2x plus 2. If I put a 0 in for the y and then a 0 in for the x, That's going to leave me with 0 is less than 2, less than or equal to 2, and that is true. So my test point is here. So the second inequality, we will solve for y. So plus 8x on both sides. And we'll change this to an equal sign as we work through it, so we don't have to worry about it. So 4y equals positive 8x plus 17. And then divide by 4, divide by 4, divide by 4. Y equals, and then I've got 8 divided by 4, so that gives me 2x plus. And since we're graphing, I can change 17 divided by 4 into a decimal, so it's a little easier to tell where that is when we graph. So 4.25. So my m is 2 over 1. The b is 4.25. So when I graph this, I'm going to start at 4.25. So it can be just, almost just a little past the 4. And then I'm going to go up 2 over 1, up 2 over 1. So really these points are just right along the blue line. So they end up, and let's see, this will be dashed because of this symbol. And if I put the original, let's see, we'll do this color. So the original inequality, if I put a 0 in for the x and a 0 in for the y, greater than 17. So is 0 greater than 17? That answer is no. So here is my test point. And this line is dashed, and it runs right alongside the blue line. And since I have a no here, I shade where that 0, 0 is not. So that would be on this side of the equal sign. So the double shading is where the solution would be. But as you can see, all the green is over here, all the orange is over here. In the middle is that blank. So this actually ends up being, I'm trying to decide where to put it. This ends up being no solution because there is no double shading. There's just shading on one side and shading on the other. So that ends up being a no solution. And sometimes that does happen.